Hi everybody, this is Eduardo Suarez. Today I want to talk about an important topic in iRVision, that is the camera selection. If you look at any of my previous iRVision videos, you're going to notice that I selected the camera arbitrarily and everything worked just fine. That is not going to be normally the case in the real world. The camera selection goes hand in hand with the application that you have, and as we're going to see in a moment, there is not a single camera that can be used as a multi-purpose camera to fit all the applications. In this video, I'm going to show you some of the fundamentals of camera selection, and we're going to look at the parameters that you have to consider when you select your camera and lens. One of the other important things is that the calibration grid that you're going to select for the camera calibration is going to be totally dependent on the size of the field of view of the camera. In other words, the size of the field of view dictates the size of the calibration grid. Let's start by looking at the following application. In this case, we have a fixed mounted camera that probably is going to be mounted on a stand. It will have to be mounted high enough to make sure that there is not going to be interference with the movement of the robot. On the other hand, we know that the part that we're going to be looking at with the camera is going to be qualified on the X and Y position. So we know already that we have two constraints. One is going to be the standoff distance, that we know that we cannot make it smaller, otherwise the robot is going to hit the camera. And the other constraint is going to be the size of the field of view, that has to be small enough to just look at the location of the part. When we consider the camera and lens selection, there are four parameters that are going to be interrelated. We're going to have the image sensor size, that in this case, we're going to look at the sensor width, and this sensor width is going to be determined by the manufacturer of the camera. We're going to have the focal length. The focal length will be the distance from the camera sensor to the focal point when the lens is focused at infinity, where the focal point is the point where all the light rays converge for the image. Wide-angle lenses have a shorter focal length. Telephoto lenses have a longer focal length. So if you want to keep the same field of view, there is a proportional relationship between the focal length and the standoff distance. The longer the focal length, the longer the standoff distance to keep the same field of view. We're going to have the standoff distance. The standoff distance is going to be the distance from the focal point of the lens to the object to be viewed. The closer the camera is to the part, the smaller the field of view. Conversely, the further away the camera is to the part, the larger the field of view. And finally, the field of view is going to be the area where the camera is going to see the part. We need to adjust the field of view in such a way that the image is going to be in focus. If we know that the part is going to be moved around, we need to consider all the area where the part is going to be possibly located and add about 10 to 20% more of the distance to calculate the field of view. In this case, we're going to look at the width of the field of view. So all these parameters that I've talked about are related by the equation that is shown below. So we have one equation and only one degree of freedom. You will have to decide what parameter you want to calculate based on the other three predetermined parameters. Now I'm going to walk you through the process of selecting the camera based on this equation. We're going to use the Fanuc lens selection calculator. This is an Excel spreadsheet that used to be available for download from the Fanuc Fridays webinar on the fanucamerica.com portal. Now, Fanuc has changed the layout of the website and it's no longer available. You will have to contact Fanuc if you want to get it. what this spreadsheet is doing, based on the selection of the camera on the field that we have in here, is putting the formula that we saw before in a tabular way. If you don't have this spreadsheet, there is another way we can do the same calculation. We're going to open the web browser and we're going to look for the lens calculator. And we're going to select the Cowell lenses calculator. Over here, you're going to see that there are 3 steps. The first step is going to be select the sensor size. The second step, what do you want to calculate? And the third step is the optical criteria. So in this case, we can just select by camera. You can pick up one of the cameras in here and select the sensor model. On the other thing that we can do, we can just select the sensor size. That in our case, we know that is going to be 1/2 inch. If we go back to the work cell and we select the camera, we're going to go to settings, and you're going to see here that the camera that we have is a 1/2 inch size, and it's going to be 1280 by 1024 pixels. And we have the focal length, it's going to be 25 millimeters, and we have the standoff distance, it's going to be 850 millimeters. So based on this information, what we're going to do, we're going to go back to the calculator and we're going to select 1/2 inch for the sensor size. The next step is going to be, what do you want to calculate? And we know already that we have the standoff distance that we saw that would going to be a fixed parameter. We're going to have 850 millimeters. So we're going to calculate is going to be the field of view. We're going to select over here, field of view. And we're going to select in here the work distance is going to be our standoff distance. We're going to select the unit in millimeters. And we're going to type 850 millimeters. Then the next parameter that we want to use is going to be the focal length. That in our case, we have a focal length of 25 millimeters. So we want to select in here 25 millimeters. And this is going to give us the field of view in millimeters. That is going to be 210 millimeters by 160 millimeters approximately. So this is the field of view that we're going to have in here. So based on this information, we know already that the field of view is going to be too big. We know already that the part is not going to move, so we don't need such a big field of view. We're going to make the calibration grid visible, and you're going to see that the calibration grid is going to be too big for the part that we have. So we need to do now the reverse process. We need to reduce the size of the field of view to accommodate to the size of the part that we have and the possible locations where the part is going to be located. And based on that field of view and distance of distance, we need to calculate the focal length. So what we're going to do exactly the inverse process. We're going to select another fixture. We're going to make this one invisible. We're going to go to fixture. We're going to add a fixture. And we're going to look for a smaller calibration grid. We're going to select this one in here. And we're going to make it visible. and we're going to bring it over the part. Okay, we have the new calibration grid over the part, and what we can do in here, you can notice that this calibration grid is more suitable for the position of the part, and we can find out what is the distance of the dots. We can go from this point to this point, and we can see here that this is going to be a 7.5 millimeter calibration grid. So now what we can do, we can find out what is the size of this calibration grid. We're going to go from this point to this point, and we have an area of 108 millimeters by 85 millimeters. So what we're going to do, we're going to go back to the calculator, and instead of selecting the field of view, we're going to select the focal length. Now we're going to have the working distance, it's going to be 850 millimeters. And the field of view is going to be in the horizontal. We can select 110 millimeters. And on the vertical, we can select 85 millimeters. And based on that, the calculator is giving us a focal length of 45.4 millimeters. So we can go back over here. Now we can select our camera, and we can change the focal length. We can go to custom and select in here 45 millimeters. And you can see that the field of view has reduced to the size that we were looking for. We can apply the same process using the Fanuc lens calculator. We're going to go to this tab over here on cameras, and you can see that the camera that we have is the Kowa SC100C. That's going to be 1280 by 1024 pixels. So we're going to select this one. We're going to go to back to lenses, and on this field, we're going to select this one in here. If we look at our camera, we have a pixel spacing that's going to be 5.3. So we need to change the cells size to 5.3. We're going to go to the camera, and we're going to change this one to 53 and 53. Okay, now what we're going to do, we're going to change the standoff distance. We're going to select 850 millimeters. And for the field of view that we have, that's going to be almost this distance here. If we select the measurement tool again, it's going to be 808 by 85. That the closest field of view that we have is this one in here. And for that, we're going to select the focal length of 50 millimeters. So we can go back in here and select 50 millimeters, and it's giving a distance very close to the one we had using the Kowa lens calculator. So one more thing, you want to make sure that the calibration grid that you're selecting, it has to fit on the field of view. You don't want to use a bigger calibration grid or a smaller calibration grid, so you have a better calibration for the camera. Now we're going to look at another application. In this case, we have a robot mounted camera So we're going to have more flexibility on the stand of distance. We're going to consider that the part can be located in any position on the surface of the table. So our field of view is going to be all the surface of the table. We can measure that. We're going to use the measurement tool, and we're going to go from one point to the other one, and we have 1000 by 600 millimeters. We want to select the camera, and we're going to change the stand of distance to 1000 millimeters. And now what we want to do, we want to select the focus lens in such a way that we're going to cover all the table. We're going to go back to the lens calculator, and in this case we want to change the stand of distance to 1000 millimeters. We're going to use the same camera, and the closest that we're going to have is going to be this one in here. Probably it's going to be a field of view of 1100 millimeters by 900 millimeters. So the focal length that we're going to need is going to be 6 millimeters. So we're going to go back in here, and we're going to select customs, and we're going to select 6 millimeters. And this is the field of view that we're going to have. So now what we can do, we can move the robot a little more to make sure that we are on the table with the field of view on the table. And this is a representation of what the camera is going to see. In this case, you can see that we're going to need a bigger calibration grid. Probably we're not going to have any calibration grid from Fanuc that is going to be big enough, but you can create your own calibration grid, or you can use the robot auto-generated calibration grid. One more thing that you can see from this spreadsheet over here, in our case, you can look at the F point. Just remember that the F point is going to be the aperture, and this number are opposite. The smaller the F point, the bigger the aperture. So we're going to have, if we select 1.4 as a S point, we're going to have a depth of field that's going to be 2.6 millimeters. And if we close the aperture and we go with a F point that's going to be 16, we're going to have a depth of field that is going to be bigger. In this case, it's going to be 6.25 millimeters. Just remember, if you close the F point, you're going to need more time for your exposure, because now you are reducing the light that's going through the camera. In conclusion, you can see from working with the lens calculator that you're not going to be able to have one camera with one lens that can fit all your applications. For the camera and lens selection, you will have to consider 4 parameters: the camera sensor width, the focal length, the stand of distance, and the field of view. That they are interrelated through the single equation as I show you in the picture.